Wait, is this going? I don't see the timer yet. There it goes. Oh, it was recording. I feel terrible. Okay, CS262. On the chance that I don't come to lab tomorrow, which at this point is starting to look more and more likely, I wanted to give you some advice on how to use JUnit. So, you're going to get a starter package, which is basically a zip file that contains an Eclipse project, which you're going to follow the instructions of the Eclipse tips from the lab description and go ahead and install or import into your workspace. And if you don't already have a workspace, you're going to set one up probably in your Z drive or on your laptop or something like that as per the lab instructions. Please actually read the Eclipse tips on how to import things. You have to make sure you're importing existing projects from an archive file. Excuse me. Every year students don't do that, and every year it doesn't work. So you're going to have these basic filter test, which has a bunch of examples that we did in class. You're going to have Enron spam test. I'll explain what this does. This is actually really cool. Classifier. This is the API. So this is the definition of all the methods you need to provide. And spam classifier. This is where your code's going to go. Everything's initially throwing unsupported operation exception. Just basically everybody's throwing an exception. So basic filter test I talked about in the last pre-lab about this. Let's talk a little bit about Enron spam test. And you're going to have just this base classifier package. I'm actually going to work with my base classifier solution package, which you notice has like a grading test in it and two different implementations. We're just going to focus on, and it's got a copy of the test cases that you had. We're just going to focus on this file, and that file. And it's they're all using this common interface up here. So to run things, you can run all the test cases by right-clicking and saying run as JUnit test, and then it runs. If you get back this green, that's a good sign, everything worked. Any stuff that gets printed gets dumped here. I kind of stuck in an extra test case that just kind of prints the probabilities of just a bunch of stuff in an array, so you can just check the probabilities of a bunch of words that are in there. This Enron spam test, we can kind of do the same thing here, run as JUnit test. Now, if you want to run just one test case, like for example, basic filter test, maybe we just want to do test please. You can click on it in the outline and say run as JUnit test. This, you'll notice, just runs the one test case. You can also kind of right-click on the method here and say run as JUnit. That'll run just the one test case. You actually can also get it here in Package Explorer. You can open this up and say, test foo, run as JUnit test case, and that'll just run the one test case. You don't always have to run everything in the test suite. You can run them one at a time if you'd like to. Now let me show you what's going on with this good old Enron spam test. I'll go ahead and make this bigger. You'll notice what this is doing. It's creating a spam classifier, setting a threshold, and it's reading all the spam files in Enron 1 spam and all the ham files in Enron 1 ham. So that's similar to what we've always done. Then what it's doing, we've got test ham 1. It's taking a file out of ham test. So what I've done is I've actually got two messages from the ham that have been extracted to here and two messages from the spam that have been extracted to here. So what we're doing is we're training on everything but those messages. Then we've got one test case where we test that one message. The probability here should be well under 0.01, so less than 1% chance that it's spam, which pretty much means it's going to be ham. And I'm not picking a specific probability. When I ran it, this is the number I came up with. Depending on how you implement it, your number might be a little bit different. I'm just saying, well, it should be less than 0.01. Similarly, down here, we're saying it should be less than 0.01. For these that are spam, that's the number I had. I'm just saying, well, it should be greater than 0.99 These messages are just highly, highly, highly spammy if we go ahead and run this. So that's kind of what's going on there. We're just holding out a couple of things to test against, and then, these are the easiest methods ever. This is just asserting that if we take our filter and we say, okay, is this message spam, it should come back and say true with a spam message, and it should say false with a ham message. So you can sort of imagine that the is spam method is really just going to compute the probabilities and compare it against whatever your threshold is. Excuse me. So that's what's going on here, and how the whole testing is working, and how some more. I may have run JUnit stuff in the other sort of pre-lab thing I had done. I don't really remember, but I wanted to give you some more information on how to run JUnit. And if you want to add your own JUnit tests for some reason, like for example, you could always go in here and say, well, I want a new test case. The keys here, it's always public void. By convention, you started out with the word test. So test, I don't know, ASDF. No parameters. You want to throw what's called a lazy exception. By throwing exception here, this means you don't have to do any exception checking inside the method body. And you stick this little at test annotation on it. And then you just put whatever code you want in here. It's now as if it were a main method. And if you have some assumptions you want to make, you can put in assertions. Those just kind of look like this. You can assert equals an expected value to a value that you've computed from your program. For doubles, you have to include an epsilon value. For integers, you'll note up here, we don't have to do that. We can just say, test basic stats, assert equals 2 to the number of ham messages. Now you might ask, well, how is this filter getting populated? Remember, we also have the setup method with this little before thing. This means that this gets run before each test case. Actually, I can't remember if it gets run before each test case or just before all the test cases once. I think it gets run before all the test cases once. I'm not really sure. There's documentation if you want to look that up. For these particular things, it doesn't really matter because we just read in the training data once. So that's what's going on here. I'm now pretty confident that my implementation actually works correctly. I was working correctly before. I was just getting numbers different than what we saw in class today, and that's because, of course, I tried changing the messages at some point last year, and then didn't leave any comments for myself that I had done that, and so I had an extra sentence in one of the messages over what we were looking at today. So, bad on me for that. Cool. Well, that's what we've got. Good luck. Oh, I should also mention, while I'm at it, that I added in sort of a challenge part to this to try to improve your spam filter. So currently, we're treating all punctuation as words, so period is a word and semicolon is a word. That may not be that useful. Excuse me. We're also ignoring words that are near 0 or 1. What if we were to cap the spamicity at 0.95 and 0.5, so we weren't to ignore those words that almost always show up as spam or almost always show up as ham? What if we were to sort of cap those values and then factor those in? Would that make any difference? And also, let's try to determine the spamicity of the punctuation. Should we ignore it? Is it close to 0.5? What does it look like? What are the 10 most spammy and least spammy non-punctuation words, or maybe they are punctuation, but what are the spammiest and hammiest words in the data set? What are the least useful words? I may add one or two things to this, but just write some code, which if you'd like can actually be a new JUnit file, maybe with some new test cases, that'll print out some of these numbers from your code and kind of figure this stuff out. You may want to add new methods or something like that to produce some of these values, but I think it would be pretty interesting to try to check some of this stuff out, do a little bit of introspection, and just see if the values seem to make sense, and then report on what you figure out. And this is where the pair programming is really helpful, because this is kind of the fun part. This would be like the cool clicker question, not the one that's like, hey, solve this formula, but the one that's like, discuss the trade-offs of this. So I'm hoping that this will be the interesting part of the lab. And of course, if it's not, I'll just continue to make improvements, and hopefully it'll finally be like the awesome assignment that I've always wanted it to be for next year. Great. Okay, go do this and let me know how it goes.